Okay, good evening. We are going to learn today about force, and we are going to learn impulsive force. Impulsive force, we are going to learn under safety features in the car. Safety features in the car. So, force, first of all, force. Okay, force. Force definition, we call it pull or push. Okay, the ability to do work, something like a definition for force. Okay, the force, and the first of all is Newton's second law of motion. Force, Newton's second law of motion. Newton's second law of motion. What is Newton's second law of motion? Say so. Newton's second law of motion. Okay, the force is directly proportional to the rate of change of momentum. Force is directly proportional to the rate of change of momentum. So, force directly proportional to the rate of change of momentum. Rate of change of momentum. So, the F equals to m, the V minus U over T, and F equals to m. These are V minus U over T. M is we separate out m V minus U over T. V minus U over T is equals to A. So F equals to ma. This is the formula. F equals to ma. The F equals to ma. The F we call resultant force. F we call resultant force. Newton. The formula, the unit is Newton. Resultant force. Combined force. And M equals to mass. Unit is kg. A equals to acceleration. And the unit is meter per second square. Okay. F equals the resultant force. M equals to mass. A equals to acceleration, meter per second square. And we're going to learn some simple questions. How we're going to use the formula. We're going to use the formula for, we call it the force formula. Okay. First of all, force involving Newton's second law of motion. Newton's second law of motion states force directly proportional to rate of change of momentum, mv over t. So the m we can divide, we can separate v minus u over t, and v minus u over t is a. A means acceleration. Acceleration, the formula is v minus u over t. So ma. So in short, ma. F equals to ma. So F equals to resultant force, m equals to mass, a equals to acceleration. Okay. We're going to do some questions. We're going to do some questions. And the first question. This force is 10 Newton. Let's say force is 10 Newton. Okay, and there's no friction. So this question, force is 10 Newton and the mass 2 kg. What is acceleration? Acceleration of this object. So F equals to ma. So F equals to 10 Newton. The m equals to 2 kg. The acceleration is we don't know. So the acceleration equals to 10 divided by 2 is 5 meter per second square. 5 meter per second square. Okay. 5 meter per second square. So, second question. This force F1 is 10 Newton. F2 is equals to 5 Newton, and the mass is 2 kg. There's no friction, no say again. No friction. They never say about friction. So what is A? So this force, they act opposite direction. Force 1 and force 2. They act opposite directions. So we have to take the bigger force minus the smaller force. Bigger force minus smaller force. So to find the resultant force, we have to find F1 minus F2. F1 minus F2 equals to MA. F1 minus F2. It's not necessarily F1 minus F2. Could be F2 bigger than F1. So in that case, F2 minus F1. The resultant force never get negative value. The resultant force F equals to MA. The resultant force F will never get negative value. You must get always positive value only. So it is a depend bigger force minus smaller force. The bigger force minus a smaller force. So bigger force is 10 Newton. The smaller force 5 Newton, and the mass is 2 kg and A. 10 minus 5 equals to A equals to 5 divided by 2 is 2.5 meter per second square. 2.5 meter per second square. That is acceleration. That's acceleration. 2.5 meter per second square. Okay? And question number 3. This is F1 is 10 Newton, F2 is 5 Newton, 2 kg, and the friction, there's a friction 2 Newton. That's a friction on the ground. So the first two questions, no friction. Question number 3, there's a friction. Okay? And to find the resultant force, find A resultant force. B acceleration. The resultant force acceleration. Okay, and to find the resultant force acceleration. Okay. First of all, question A. Resultant force. The resultant force, to find the resultant force, and we have to find the bigger force minus smaller force, and the friction is always minus at last. The friction you minus at last. The friction. You must consider the bigger force minus smaller force, applied force. These are applied force. These are the applied force. So you must consider the applied force. Same direction applied force, you plus same direction. If the force applied force at opposite direction, you take the bigger force minus smaller force. If the forces at opposite direction, applied force at opposite direction, you take the bigger force minus the smaller force. You take the bigger force minus smaller force, and the friction, if there is a friction you minus finally. You minus friction finally. Okay, the resultant force is F1. The bigger force F1 minus F2, and the friction you minus friction. The minus friction. Friction must be always minus, and friction must be minus finally at final. So friction, you must minus friction. You must minus friction. You not plus friction. You minus friction, and you minus friction at finally only finally. Okay. So F1 is 10 Newton, F2 is 5 Newton, and F friction is 2 Newton. So is 10 minus 5, 5 minus 2 is 3 Newton. So resultant force is F means resultant force 3 Newton. So question B, F equals to MA. So the resultant force 3 Newton. The mass is 2 kg. A, we don't know A. A is 3 divided by 2 is 1.5, I think. 1.5 meter per second square. 1.5 meter per second square. That is called acceleration. That is called acceleration. Okay, I would like to give on homework this question, one homework question. You try this question. Besides the question paper, I will give the question paper also. But you must try one question. Okay, we call it question number 4. This is question number 4. Question number 4. All these forces acting 90 degrees surface, 90 degrees surface. So F1 is 10 Newton, F2 is 5 Newton, F2 is 5 Newton, F3 is F3 is 15 Newton. F2, F3, F1, 3 forces, and the friction is 2 Newton. Find a resultant force. Resultant force is the final force. Resultant force, final force. After minus, plus, all the forces. Okay. Resultant force. And question B, acceleration and direction. Question B, acceleration and the direction. Question B, the acceleration and the direction. We have to find the acceleration and direction, the resultant force. Okay, and your F1 is 10 Newton, F2 is 5 Newton, F3 is 15 Newton, friction is 2 Newton, and the resultant force. The resultant force and acceleration and direction. Acceleration, direction. This is question 4 as a homework for you. And there's one question. We have to do one question. And that question. Okay. This picture. This booklet or paper. Okay. This question number 2. Page 8, I think, page 8. Page 8. Question number 2. Question number 2. A and B. We try to do question A and B. Question A and B. Question A and B. Okay, we are going to do another question. One question. We are going to do one question. Okay, we are going to do one question based on the we call it okay. I saw this one question, the pulley system question. Okay, I saw the pulley system question. So the pulley system question like this. Pulley system question. Okay, this is a frictionless pulley. Pulley is something like a tilaga, something like from the well you take the water from the well. So the pulley is something like raising the flag in the daily morning assembly in school. In the school assembly in the daily morning, you already call it raising the flag. So the pulley is what they call it spinning lah. So but that pulley is a friction, the pulley with the friction. But this is a frictionless pulley. Frictionless pulley. So 2 kg and 3 kg. 2 kg and 3 kg. Okay, we hold this object. These two objects, we hold it. Okay, we hold these two objects. We hold this object and we lift hand. What happened? What happened? This 3 kg moved down with acceleration A. 2 kg move up with acceleration A also. Same acceleration because they are tied, both objects, 2 kg, 3 kg object, they tie in by the same string. The same string. So, regardless of mass, they will move down upward. So, the 3 kg move downwards and the 2 kg move upwards. That is 3 kg move downwards, 2 kg move upwards. 3 kg move downwards, 2 kg move upwards. So, and they move both through 3 kg move downward, 2 kg move upward with the same acceleration. So, we call it acceleration of the system. Acceleration of the system. So, we are going to do the question, and we are going to do the question. We are going to learn a tension. We are going to learn a tension. There must be tension. Tension in the string. Because of 2 kg pulling down, the tension is pulling down. The tension pulling down. And the tension other side also must be same. The tension must each other meet each other. This point, this tension. Okay, because of 2 kg is pulling down also, pulling down. So tension, each tension meet each other. Each tension meet each other. So the tension and the tension. So the question asking you, find a acceleration of the system, both move down, move up with the same acceleration. And question B, find the tension in the rope. I saw this question, one of the questions in the syllabus. So I like to teach this question. Okay, they give so many, maybe I don't know the depth of the syllabus, don't know yet, but they ask some questions about tension questions, about pulley system question. Okay, and A and D. Okay, and A. Okay, now we are going to do the question by considering the weight, all the forces acting upon the 3 kg and the forces acting upon 2 kg separately. So 3 kg, we put 3 kg, sorry, I put black ink. Okay, 3 kg object. Okay, we are going to see the 3 kg only. The 3 kg move downwards. So move downwards means there's a one force called mg. Mg means weight. Mg means weight. Okay, and this force also mg. There's one force mg means weight. Weight, W equals mg. Mg. M times gravity. So the M, this 3 kg want to pull down because 3 kg is heavier. 3 kg heavier. So want to pull down, but at the same time there's one force trying to pull up. That's called tension. So mg minus T, because these two forces acting different directions. But mg must be greater force because because 3 kg coming down. Because mg 3 kg coming down, so the weight pulling down. So weight must be bigger than T. The weight of 3 kg is bigger than T. So mg minus T. Different direction force, different direction must minus. Same direction must plus. Equals to ma. Ma means resultant force. So m equals to 3 kg. G, let's consider G10. Let's consider G10. Some book they mention G is 10. Not like 9.81. So 10. We take 10. G is 10 and T and m equals to 3, 8. We don't know 8. So 3 times 10 is 30 minus t equals to 3a. This is equation number 1. 3 times 10. Let's take g as 10 because I saw the syllabus book. The question g we take as 10. Okay. Sometimes you can take 9.81. So depend on the question. Okay, 30 minus t equals to 3a. And then we consider the 2 kg object. 2 kg object. We consider 2 kg object. So 2 kg object is going up or down? Going up. So going up, the force helping the object to go up is a T. Helping the object. Pulling the object upwards. T is pulling up. But at the same time, there's one force try to pull it down. However, it cannot pull it down. Because the T is greater than mg. So the mg is trying to pull down, but the T is bigger than mg, that's pulling up. So T is pulling up. So the formula, the equation, T minus mg equals to ma. T minus mg, because this force is greater force. T pulling up, because the object 2 kg go up. 2 kg go up. So mg is trying to pull down. So the two of opposite direction force. So T minus mg equals to ma. So T m equals to 2, g equals to 10, equals to 2a. 2. So T minus 20 equals to 2a. So T equals to 2a plus 20 is equation number 2. T equals to 2a plus 20, equation number 2. So this simultaneous equation, you must solve the simultaneous equation. Okay. T equals to a plus 20. So this equation number 1. 30 minus t equals to 3a, and t equals to 2a plus 20. Equation substitute. Equation 2, equation 1. So substitute. So 30 minus. So t equals to 2a plus 20. So t, in the place of t, you can t 2a plus 20 equals to 3. Equation 1, equation 2. Equation 2 substitute equation 1. Equation 2 substitute equation 1. Okay. So 30 minus 2a minus 20 equals to 3a. Okay. And a one side, number one side, like 30 minus 20 is a 10. 3a plus 2a minus 2a plus 2a, bring up plus, okay. 10 equals to 5a. So a equals to 2 meter per second square. A equals to 2 meter per second square. A equals to 2 meter per second square. Okay. And next question, we are going to find a T, tension. Okay. We can find equation 2, equation 1. So equation 2, T equals to 2a plus 20. So T equals to 2a. A means must be 2 plus 2. Sorry. 2 is must be 2. 2 plus 20. So T equals to 2 times 2 is 4 plus 20. 24 Newton. Tension is a force. So 24 Newton. Okay. I would like to give 2 questions as homework for you to do this. I like to give 2 questions. Okay. The first question number 2. find A acceleration, B tension. This is a question. Okay, this is a question. Okay, find A and B tension. Question number 3. Question number 3 is a different question. It's a different question. There's a pulley here. Pulley 3 kg. It's a 2 kg and 3 kg object. There's a table. It's a table. In the table, there's a pulley and there's a friction. There's a friction. Friction is equal to 2 Newton. So the question asks you find A acceleration, B tension. So I like to give some tips for you. The tension is this way. This tension. This is mg. And this is the tension. Okay, this mg, the weight, tension is this way. So find A and T. Find A and T. Okay, and I would like to end this class with this. The next class may be coming Thursday, Friday, or like this. We are going to do one more class, and that time I'll teach you more detail about force and impulsive force. Okay, thank you very much. You please do the questions. Okay, and plus this question, the paper question. Thank you.